Hello, I'm here to talk about vacuum plugging. So vacuum plugging is when a vessel, in this case I've got a syringe, and in some cases syringes will be capped off, or otherwise there's going to be a closed end of the syringe. And so we want to fill a liquid in there and we want to cap it from the back side. So that's where vacuum plugging can be applicable. So what I'm going to do first here is I'm going to manually fill this with 2 milliliters. I'm going to do 2 different samples. I'm going to do one under a very nominal vacuum, so more or less atmospheric pressure. So right now I've got a little discrete sensor here that is measuring the vacuum, and I've set it so that at 5 inches of mercury it triggers. So in this case what happens is I'm gonna load up, I'm gonna fill, I'll go ahead and do it here. I'm gonna fill one of these here with if you can see this, I'm just gonna put 2 milliliters of just plain water in here, and I'm going to load this into a tool. And what this tool does is allows me to apply vacuum to this entire chamber, okay? And then above this tool, I'm going to load in one of these plungers. So what we're going to do is we're going to evacuate the air to that 5 inches of mercury vacuum, and then we're going to press that plunger into the chamber. So here we go. We're going to load this in. That's going to close. It's going to hit its vacuum target, press it in, and then here we've got that package. So what you can see is that there's a considerable amount of air there, because as soon as it pressed in, it's meeting air that's in the chamber, and that's providing a force back. So now I'm going to go in and I'm going to change the threshold value of this vacuum. I'm going to crank it all the way up to 29 inches of mercury, which is nearly a whole atmosphere. You know, you're talking about at 5 inches of mercury, you're at let's call it 9/10, roughly somewhere around there. I could give of an atmosphere, but at 29, you're at like 1/30th of an atmosphere. So here we're going to fill it with the same 2 milliliters of water here, and I'm going to take the same plunger, and as I said, I've changed my set point here. And then I'm going to run this. So it's to hit the vacuum, press that in. And so there you go. So now, if you look at our two samples here, the one that we had under relatively high vacuum just has a very small bubble there, whereas the other hit the air and stopped. So now the next thing of note is that when I fill this chamber, depending on the viscosity of what I'm filling it with, so in this case it's water, but if I'm filling this with a higher viscosity thing, well, any fill is going to want to, and I'm going to take the cap off of this, there's that very fine orifice there and chamber at the end of this, And if you have valving or whatever you may have at the end, you may have an even greater volume there. So that volume, when you load in the liquid, it is to be expected to trap some air in that small orifice. So here I've got one that's been filled, as I said, just at atmospheric pressure. Now I'm going to take one, and right here I've got a system for pumping under vacuum. So what's going to happen here is the chamber's going to get closed. We're going to apply the vacuum. We're going to shift this valve here to pump, and then we're going to pump in the liquid that's inside this ore. And then we're going to shift the valve again up to what is the tank here, and we're going to retract the piston, which is going to charge it for the next run. So here I've got, as I said, my syringe, placing that in my tool, and I'm going to load that in here. Okay, so we hit the vacuum level real quick, and we loaded that in. Okay, and so that's great. I've just taken the air out, and then I've pumped a liquid in. Okay, so that's a pretty stable thing. First of all, you'll note that this, because it was pumped in under vacuum, doesn't really have these even like bubbles that are on the side, and that's just trapped air from surface tension. So now I'm going to, as a demonstration, I'm going to bring you in a little closer here. As a demonstration, I'm going to come in here and I'm going to apply vacuum to these two different. So we've got the one that was hand filled on the right, and the one that was vacuum filled on the left there. And I'm going to apply vacuum and show you what happens between the two. And so what I'm telling you is that air. Oh, gotta close my chamber here. So I'm applying the vacuum, which is shown up there, and you'll see there's a bubble. See that bubble, how it's forming from the tip. So that bubble is trapped air. That because that was filled at atmospheric pressure, it was trapped by surface tension down there. So if I increase the vacuum, when I increase that vacuum, the size of the bubble is again expanding as a function of Boyle's law, you know. Now I'm going to stop the vacuum, and what you saw is that, you know, there were no bubbles that came out of this. It's very stable. And now I'll release the vacuum. So why is that relevant? Well, if you're trying to get the least amount of air in your package here, you want to get that air out. You want to get that air out before you even trap it. It's certainly an option too, you know. So here we've got our one filled under vacuum, and because now we kind of know that we didn't trap any air down there in the bottom tip, and we're going to load this in, and I'm going to take another plug and load it into my horn here. And again, we're still at the same vacuum level here. Pressing it in, now we're releasing. And so there you go. So we've kind of trapped the least amount of air that we kind of can. And we've also made the fill itself more stable, meaning that when the vacuum is applied at the plugging operation, the likelihood of air being trapped in these tiny crevices at the bottom of the fill, the likelihood of that is much lower. And if there is air in those tiny crevices, it's going to try to expand and basically bubble out when you apply the vacuum, because that bubble goes from small size at atmospheric pressure to when you're reducing the pressure level in here, creating the vacuum, that bubble, as you saw in the chamber, they expand. So that expanding bubble at the time of plugging, that expanding bubble can come up to the surface of the fill and splash. So meaning that it can, if you were filling, especially with a higher viscosity item, it's going to want to bubble up and blow like a balloon. So the problem that you incur in your process is that bubbled liquid can spill over and expose itself to whatever horn it is that you're using to guide the piston into the plug. Into the syringe. So that's my quick demonstration. Hopefully that's helpful for you. Boyle's law. Here's where it applies, and where you can use the knowledge of Boyle's law to your advantage. So, and then I'm going to take a pumping apparatus right here. Okay, so we're ready to pump here. And that gets to a peak of 28.5 inches of mercury.